Cool. So that we attempt to do, like I said, number 1 and number 10. So number 1, cosine theta plus 1 is equal to 0. In all of the previous examples, we had sine theta is equal to k, cosine theta is equal to something, tan theta is equal to something, and so on. So it's only natural to have our trigonometric equation in a particular form. And that form is sine theta, cos theta, or tan theta is equal to k, where k can be anything, a number, fraction, a negative, a positive, it doesn't matter what it is. So I'll rearrange a little bit here. So I'll have cosine theta is equal to minus 1. First thing I ask myself, cosine is negative. Next thing I ask myself, where is cosine negative? I know all school teachers, cos 1 and 3, it's positive. So as the previous question we did, in quadrant 2 and in quadrant 3, it'll be negative, sorry. So in 1 and 4, it's positive, and in 2 and 3, it's negative. So the first thing I try to do in all my questions is to draw my mini quadrants. Attempt to calculate my principal value. My principal value is equal to cosine inverse the modulus of minus 1, which is cosine inverse of 1, which should be 180 degrees. No, cosine inverse of 1 is 0. Let's check it here. Cosine inverse of 1 is 0. Now, my solutions lie here, and my next solution lies here. I know theta is 180 minus my principal value. 180 degrees take away 0, which is 180 degrees. All well and fine. Also, theta is 180 degrees plus the principal value, which is 180 degrees plus 0, which is 180 degrees. So in my first revolution, theta is 180 degrees. I have to check in my next set of revolutions. Well, in the second revolution, theta will be 360 degrees plus whatever angle I got in my first revolution. Well, the only angle I got in my first revolution is 180. So I get 3 and 1 is 4, 1 is 5. I get 540 degrees. Now, as soon as I go outside of 870 degrees, that's going to be the time when I'm going to stop making solutions. So I'll go in the third revolution. So in the third revolution, theta will be 360 degrees plus the angle I got in my previous revolution, which is 540 degrees. I get 6 and 4 is 10, 5 and 3 is 9, and 1 is 10. So this is 1,000 degrees. It is out of the domain. So out of the domain. So my solution states that theta will be 180 degrees and 540 degrees for this given domain. 0 degrees is less than or equal to theta is less than or equal to 870 degrees. And number 10, I have tan squared theta is minus 3 is equal to 0. Now, this is important. This is extremely important. As stated before, I want to get sine theta is equal to k, cos theta is equal to k, tan theta is equal to k. Over here, I have tan squared theta minus 3 is equal to 0. Let me try and get tan squared theta is equal to k. So I end up with tan squared theta is equal to 3. Now, the symbols we use on trigs with respect to exponents, it works a little bit differently, a little A little strange, a little strange. If I have long time, xy all squared, well, this was x squared, y squared. If I am comfortable with this, and I try to transition into something like tan theta all squared, naturally you'll gravitate to having tan theta squared. Naturally, that's what you gravitate to. Or you'll gravitate to tan squared theta squared. The angle found in a trigonometric ratio or a trigonometric identity is very special. You're not allowed to do any alterations to the angle, any external alterations to the angle. Meaning, if I had something like a 2 in front of here, you don't apply that 2 onto the theta. You apply it onto the tan alone. If I have a 3 up here, we don't apply the 3 to the theta, we apply it to the tan alone. So this becomes tan cubed theta. So both of these things mean the same exact thing. So if I were to change up the terminology a little bit, just for visual purposes, I would have tan theta all squared is equal to 3. I'll just change how it look. I know how to deal with a squared. I will square root both sides. And I get tan theta is equal to root 3. But it's not just root 3, it's plus or minus root 3. So in a case like this, I end up with positive values for tan theta and negative values for tan theta. I'll take one at a time. I'll first deal with the positive values for tan theta. So if tan theta is equal to positive root 3, I'll have solutions lying in quadrant 1 and in quadrant 3. Because all school teachers. So my principal value is going to be tan inverse. I don't have to put the modulus because root 3 is already positive. So tan inverse of root 3, tan inverse, open bracket, root 3, close bracket is equal to 60 degrees. All right, no problem. In the first quadrant, I have theta, which is my principal value, which is 60 degrees. In the third quadrant, I have theta, which is 180 degrees, plus the principal value, which is 180 degrees, plus 60 degrees, which is 240 degrees. That's in my first revolution. So in the second revolution, theta is equal to 360 degrees plus the value I got in my first revolution, and that will be 420 degrees, and theta could be 360 degrees plus 240 degrees, which is equal to 3, 4, 5, and 1 is 6, 600 degrees. I am going out of the domain as yet, so I'll go in the third revolution. In the third revolution, theta is equal to 360 degrees plus the answer I got in my previous revolution, which is 420 degrees. That is 3 and 4 is 7, 6 and 2 is 8. I am going out of my domain as yet. Theta is equal to 360 degrees plus 600 degrees. And I get 960 degrees. Brother man, U is out of the domain. So my solution for tan theta is positive is going to be 60 degrees, 240 degrees, 420 degrees, 600 degrees, and 780 degrees. Now I have to take the case where tan theta is negative. Same procedure. So I'll drop my quadrants again and I'll just do it down here. So this is for tan theta is equal to negative root 3. My principal value is going to be tan inverse of the modulus of negative root 3. Given that these two are the same part of the same question, this is going to yield tan inverse of root 3 which is equal to 60 degrees. Every time we had to calculate the principal value, so where's tan theta negative? Tan theta is negative here and here. So theta will be equal to 180 minus the principal value, 180 minus 60, 120. And theta is 360 degrees minus the principal value, 360 minus 60, 300 degrees. Again, first revolution. In the second revolution, theta is equal to 360 plus the angle I got in my previous revolution, 120. 3 and 1 is 4, 6 and 2 is 8, and 360 plus 300, 3 and 3 is 6, that is 660 degrees. I'll go again. In the third revolution, theta is equal to 360 degrees plus the angle I got in my previous revolution, which is 480 degrees. That is 437. And 1 is 8, that is 840 degrees. So checking. When I go outside of 870, that is when I'll stop. Me going outside of 870 as yet. Theta is 360 degrees plus 660 degrees. That going to be 6, 7, 8, 9, and 1 is 10. 10, 20 degrees. And homeboy is out of the domain. So my solution for when tan theta is negative, going to be, I had to put theta is equal to that. Nearly forget to put that, right? So if I forgot it before, make sure I put it in. Theta is equal to 120, 300, 480, 660, and 840. So both of these combined will be my solution for all values of theta for tan theta is equal, tan square theta minus 3 is equal to 0. Make sense? Understand that?